And I guess I didn't ask. Were there any questions over the quiz? Or did it all make sense? Okay. Control statements. We will be talking about things like if statements, the and sign, the or sign, the not sign, while loops, do loops, for loops, nested loops, and input validation. We've already actually covered some of this stuff. So this is just a note on their terminology. Whenever you see something inside the little angle braces like that and it says condition there, that means that that is supposed to be something that will evaluate to true or false. It's an expression. An expression can either be a variable or it can be, you know, a series of variables and symbols. Usually it's an equality expression. If A equals 3, if B less than 2, that kind of thing. So that's just what that means. The angle braces are not actually part of the code. It's what would get replaced with the code that we're going to put there. And that's just this book's way of expressing that. So Java uses several comparison operators. We've seen equal, equal before, and there's also less than or equal to, greater than or equal to, less than, greater than, and not equal to. So the way you read it is something like this. If A is equal to 3, that's is equal to. If A is less than 3, we know what these mean. Is less than. If A is greater than 3, is greater than. If A is less than or equal to, and then there's greater than or equal to. And then finally there's not equal to. If A is not equal to 3. And I think in grade school we may have used that to mean not equal. Like, you know, if A is less than or greater than 3. I don't remember. I certainly don't think that we use the exclamation mark to mean not equal. By the way, you could also, here, let me do this. If A is not equal to 3, could also be written like this. If not A equal to 3, like that. These two things mean the same thing. And we'll see why later. This is called the not operator when it's by itself. An exclamation mark all by itself is the not operator. And the way it works is this evaluation is done first, and then the not operator reverses its truthiness. So if it was true, it becomes false. So the way you would read this is if not A equal to 3. Same thing. You could do this. This is the same as, you could also do this. If A is greater than or equal to 3, this is the same as if not A less than 3. I hope that makes sense. This reverses it. So if it's not less than 3, that means that it is greater than or equal to 3. If it's not equal to 3, that means that it is not equal to 3. Same thing. So when you're flipping this condition, if you want the opposite of A less than 3, the opposite of A less than 3 is not A greater than 3. It's A greater than or equal to 3. And the opposite of A greater than 3 is not A less than 3. The opposite of A greater than 3 is less than or equal to 3. When people use the not operator, though, it makes it easier to read if you add some extra parentheses. You don't have to. So this is the not operator. it reverses the true falseness of it. So in an if statement, we know what an if statement does. This says that there's three forms of an if statement. If by itself. If greater than midnight, go to bed. Used for problems where you want to do something or nothing. Well, that statement didn't tell us what else to do. It just said if it's greater than 12, go to bed. If else. Used for problems where you want to do one thing or another. If after midnight, go to bed, else stay up and have fun. And then there's if, else, if, which is when you have three or more different options. So you could do something like this. If temperature is less than 32, print freezing. That's the first way of doing it. When you want to do something or nothing. That's form 1. Then there's if else, form 2. If the temperature is less than 32, print freezing. Else, print toasty warm. You do that when you want to do something or another thing. And then there's if, else, if. If the temperature is less than 32, print freezing. Else, if temperature is greater than 212, print boiling. Else, print just right. That's the third case. So use if, else, if you want to do one of three or more things. And it says three or more, we could keep chaining on else ifs, else ifs, else ifs, you know, and we could come up with 100 different things that we wanted it to do. The logical operators. And or. The way that works is, say we wanted to find out whether the temperature was between 50 and 90. And if the temperature was greater than 50 and it was less than 90, we wanted to print OK. Now there's more than one way you could code something like that, but some of them aren't really all that great. For example, you could do this. We're going to write some code that displays OK if the temp is between 50 and 90. Now we're kind of ignoring the fact whether it's inclusive or not. Here's one way you could do it. If temp is greater than 50, and this isn't a good way, if temp is less than 90, print OK. Why do I say that's not a good way? That does strictly match this definition. But what if you wanted to print another message? What if you wanted to change it to an if-else? Then we wind up having to put, you know, multiple else's in here in order to get it to all work. So that's one way of doing it. But a much better way, and whenever you have nested ifs like this, they often can be replaced with the and. Use and. And is represented by these two symbols in this language. In Python, you actually use the word and. In Java and C++, you use those ampersands. So you would write this like this. If temperature is greater than 50 and temperature is less than 90, print OK. I'm just going to put a comment. This is not a great way to do it. And I'll show you why. What if I did want to modify this code to print not okay in the conditions where it wasn't okay? I'd have to do this. If temperature is greater than 50, else print not okay. And then I have to stick my another else here. Okay. That's pretty lousy. We're printing not okay at 2 different times. It would be much easier just to come up here and add an else clause to this one, right? Like that. So whenever your syntax is getting unduly complicated, you can think to yourself, well, there's probably a better way to do it. That is a nasty way of getting it to print okay and not okay. This is a nice clean way. And the reason we were able to do so is because of the AND operator. For the AND to work, both sides have to be true. If this one is false, it doesn't even bother checking this one. That's called short-circuiting. If this expression is true, it does have to check this one to see if both sides are true. But if this expression is false, then it knows the whole thing is false. So to be efficient, it doesn't even bother checking the second half of the expression. Okay, now this horrible one, I'm going to delete that. That was just to illustrate why this first method is bad. This is a much better way. Oh, I was going to say something. We went from short-circuiting. I've lost it. Okay. So, both sides have to be true. You can make a little truth table for this, where you had A and B, and what the result was. Well, if A is true, and B is true, then the result is true. In all other cases, everything is false. So if A is false and B is false, the result's going to be false. If A is false and B is true, the result's going to be false. If A is true and B is false, the result's going to be false. The only time an AND will return a true is if both operands are true. So, if I had this, if A and B, then print something. When is the only time that it would print yay? When A is equal to what and when B is equal to what? Yeah, they both have to be true for this to work. That's different from an OR. We're going to talk about OR next. OR means if this one is true or this one is true. Go ahead and print yay. A and B would both have to be true. Print yay. This is known as a truth table here. This is the truth table for the AND. Why is it called a truth table? Well, because we're mixing our truths as inputs, as operands for the AND operator, and listing their results. So then there's OR. OR is represented by 2 vertical bars, shift backslash, above the enter key. So what if we wanted to modify this logic to print not okay if it was outside the range of 50 and 90? We could do this. If temperature is less than 50 or temperature is greater than 90, then print not okay. Now I'm being real sloppy because I'm not saying whether this range is inclusive or exclusive. What that means is I don't know how to treat 50. and I don't know how to treat 90. Is 50 exactly supposed to be okay? Or is it not supposed to be okay? So I'm going to say that this is inclusive. And to make it inclusive, I need to make it greater than or equal to, and less than or equal to, so that 50 is counted. If I said exclusive, I wouldn't want to make it greater than or equal to. I just want to make it greater than. And I wouldn't want to make it less than or equal to. I'd want to make it less than. And so now, print OK if the temperature is not within the range. Or print not OK. Is not within the range 50 to 90 inclusive. So the way you read this is, if temperature less than 50 or temperature is greater than 90, print not OK. If the temperature was 60, well, is 60 less than 50? Nope. If the temperature was 60, is temperature greater than 90? Nope. So it's not going to print not OK. It falls within that range. So since it's not within that range, and so the truth table for OR looks like this. A or B result false or false is a false. Only one side has to be true for the entire expression to be true. So false or true gives us a true. Because if temperature is less than 50, that means it's not okay. So if you have a temperature of a negative 1 million, it's definitely not okay. So that one was true. It didn't even care about that one. It didn't even have to check that one. It short circuits it again. If this turns out to be true for an OR, it doesn't evaluate the second operand at all because it already knows that the expression is true. All right, I'm going to move our two truth tables in our notes right next to each other.
Can you combine, use parentheses to combine and ors, like A and B or C?
Uh-huh, exactly, yes. In logical notation, you represent OR with plus, and you represent AND with times. So if you wanted to write the expression A and B or A and C like that, not in Java, but just in logical notation, you would express that as this, AB plus AC, like that. And you could use parentheses to do so. But absolutely, you can use parentheses to force some things to happen first. So, when you're using AND, only one possibility is true. That's when they're both true. When you're using OR, only one possibility is false. And that's when what? When they're both false. Okay, so two shorts. Okay, so both of them can be short-circuited. Short-circuiting is not a bad thing, and it sounds dangerous, but it just means that part of the thing is skipped. If you have AND, if the first operand is false, the second operand is not even checked. This is short-circuiting. That's just for efficiency's sake. So if you're doing if A and B, if A is false, B is not checked, not evaluated. And that could actually make some difference if these were actually function calls rather than just simple variables. So like if battery is inserted and battery is charged. Some logic like that. If this isn't true, if the battery is not inserted, there's no reason to even call that function. And if this function was something that took several milliseconds to go out and do, then the program is saving some time by not going and checking to see if it's charged if it's not even inserted in the first place. So that's short-circuiting. Let me rewrite that because that makes no sense. If you are using AND, now I need to rewrite all this for OR. It's going to look very similar. If you are using OR, if the first operand is true, the second operand is not even checked. This is short-circuiting. So if you wanted to write some logic like this, if out of gas or battery is dead, stop going. If this is true, there's no reason to even check to see if the battery is dead. We know we're not going to be going anywhere. So if you do this, if A or B, if A is true, B is not evaluated. And as you mentioned, you can use parentheses to force more complex evaluations of things. But by the time you wind up using a lot of parentheses in your expression, you maybe ought to see if you can think of an easier way to write it. So here's our example. If the temperature is greater than or equal to 50 and less than or equal to 90, print OK. Now that's pseudocode. This is not valid code. We could not actually get this to work. And the reason for that is that in coding, both sides of the and sign have to be valid expressions. Temperature greater than 50, that's a valid expression. But is less than 90 a valid expression? If I just go up to the computer and I type less than 90, does it know what I'm doing? Does it know what I'm comparing it to? No. So you have to say if temperature greater than 50 and temperature less than 90. Now people want to write it like this because that's how we think, that's how we say things. But you can't code it that way. So you can't test for a range like this. If T is greater than 50 and less than 90. That won't work. Both sides of and have to be valid expressions in their own right. So you have to say if T is greater than 50 and T is less than 90. And that's what they show here. If temperature greater than or equal to 50 and temperature is less than or equal to 90, print OK. Else print not OK. So the and sign, the program on the next slide determines whether fans of the basketball game win free French fries. If the home team wins and scores at least 100 points, the program prints the message, redeem your ticket stub for a free order of French fries at Yummy Burgers. On the next slide, replace insert code here with the appropriate code. Okay, fine. So here's our code. Home points and opponent points. We ask how many points the home team scored, and we read it in with next in. We ask how many points the opposing team scored. And now we want to write an if statement that says free fries, but we only want to do it if, what were the conditions?
Team wins and scores.
If the home team wins and scores at least 100 points.
That's what they're asking for, 100 points.
So, I've already forgotten the variable names. Home points and opponent points. So we would do something like this. If home points is greater than opponent points, and home points is greater than equal to 100, that's when we would print free fries. And then there's OR. Here's their logic for this. We're going to ask them whether we want to quit or not. And we will quit if they either type in a lowercase q or an uppercase q. Now there's other ways of doing this, but here's how they did it. They enter some code, they use, scanner.next to read in a string, store it in a variable called response, and then they do if response.equals little q or response.equals big Q, then print out goodbye. And so here's an OR. Obviously, in this particular case, it's impossible for both of these to be true. But that's okay, because OR just means one side or the other has to be true. And this is a good point to mention that I'm not sure we've made before, which is if you're comparing strings, you cannot use the equal operator to compare strings. Have I talked about that yet? Well, then we'll have to. But anyways, so if you do this, string name, and then you do name is equal to scanner dot next to read in a name, and then if you do name is equal to Bob, that won't work. All this does is see if this address points to the same memory address as Bob. And I actually never will point to the same memory address as Bob. So this would never evaluate to true. This is not how you check equality of strings. That's a little too emphatic. Instead, you have to do this. If name dot equals Bob. Use the dot equals method. And that's different for you Python programmers. You Python programmers could do that, but Python's a different language than Java. Why did I do that? Go away. So it is a common bug to forget to repeat the variable if response equals Q or Q. No, that's bad syntax. Instead, you have to write if response.equals Q or response.equals Q. Again, using the equal sign to compare strings. It'll compile, but it won't work properly if response equals little q or response equals big Q. Both of those are wrong. If you want to check to see if something matches a lowercase or an uppercase, you could just call equals ignore case. So in this code here, if I wanted to do this, that's not how you do it. Now we're checking for two variants. This is how you would do it, but there's a better way. And that would be to use ignore case. we could do this. If name dot equals ignore case. And it would compare these two strings, but ignore their case. Then we could print out hello Bob or whatever we wanted it to do. So these do the same thing. And this has the advantage of also checking to see if there's a capital B and a lowercase b. Right now, this is assuming that either the entire word is typed uppercase or lowercase. But what if they typed lower, upper, lower, or lower, upper, upper, or upper, lower, lower, or whatever? If you use ignores case, then all those conditions would match. I think I'm going to change this example though from Bob to something else. We're going to do like that. String OK. OK is equal to sc dot next. And then if OK is equal to yes, or OK is equal to lowercase yes. That's not how you do it. Instead you use dot equals. If OK equals yes, or OK equals yes lowercase. And a better way would be to just use ignores case. Since we said ignores case, it doesn't matter whether this thing is capitalized or lowercase or anything in between. This lets us skip using the or. And why might we want that? What if they type yes with a capital Y but a lowercase e s? Well, we don't want to have to check all possible permutations. Better still would be just to take the first letter and then check that, so that if they typed in a period or not, Anyways, okay, so then there's the not logical operator. I've already mentioned that one. That reverses the truthiness or falsiness, as Stephen Colbert always said, the truthiness of it. So if reply is equal to Q or reply is not equal to Q, this would be evaluated, but then the not would reverse it. So here we're saying, do you wish to quit? And they're storing that answer into a variable called reply. And if they typed a Q or they typed in an uppercase Q, then that means they do want to quit. So we're using not to reverse that. So if they don't want to quit, we will print let's get started. So our brains start to kind of get warped once we start trying to think about using nots. So it's often better to write your expression in a way that not is not required. So here we'll print, do you wish to continue? Y/n. Once we get that, we're going to check to see what they typed. If response dot equals lowercase y or response dot equals uppercase y, but we want to reverse it. So we're going to add a not to it. Then we would print let's get started.
The opposite of let's get started?
Yeah, you're right, because I'm checking for y's.
Yeah.
Thank you. There we go.
Print your recorder.
Pardon me?
You print your recorder.
I am so sorry. Please
You
repeat.
would print your recorder.
Yeah. Quitter. Okay. I probably wouldn't word it like this. I probably would actually be checking for the y's. I would word it like this. If response equals that or response equals that. I don't like having knots in there.
Yeah.
They throw my brain into knots, no pun intended. The switch statement. I'm going to skip the switch statement for now. The while loop. A while loop is like an if statement, except it repeats its condition as long as the condition is true. An if statement only does the statements once. It'll say, if A is greater than 3, do something. Well, that something only happens if A is greater than 3, and even if it is true, it only happens once. But the while statement would say something like this: while A is greater than 3, do something. That something will happen over and over and over until this condition is false. So let's go ahead and open up NetBeans, and we'll just demonstrate an if and a while for funsies, and then I'll look at the exam and see if there's anything else we want to cover as review for it. So we're declaring two variables, x and y. And we're going to write a couple of things. One is, let's say Bob, if x is greater than 3 and y is less than 10. That's the first thing we're going to do. And then let's say Joe, if x is greater than 3 or y is less than 10. And these are just silly. And then let's write a loop that displays x and then adds 1 to x while x is less than 10. And when I say, obviously I mean print. I don't think it's going to print either Bob or Joe because I happen to choose values. Oh well, anyways, the important thing is just writing it. If x is greater than 3, what's the symbol for and?
Double ampersand.
Yeah, double ampersands, and y is less than 10. System.out.print or print line. Bob. So the next one, we're going to print it if x is greater than 3 or y is less than 10. If x is greater than 3, and then or is the shift backslash, 2 vertical bars. And then let's write a loop that displays x and then adds 1 to x while x is less than 10. So we're going to write a loop, and it's going to say while x is less than 10, display x, system.out.println x, and then add 1 to x, x plus plus. Now when we run this, I don't think I'm either going to see the word Bob or Joe, but we will see some numbers because x is less than 10 currently. It's 3. And so it counts up 3, 4, 5, 6, 7, 8, or 9. And I'm sure we've already talked about the 3 kinds of loops. User query. There's another one. And then there's Sentinel. What was the first kind? When you're counting loops. That's right, when you're counting over a specific range. So this is a counting loop right here. If we were going to make it user query, we would ask them for data, and then we would ask them if they wish to continue. Yes, no. If we were going to do a Sentinel loop, we would ask them for data, and then if that data equaled a special value, we would bail out. So along with the whiles, there are 2 extra keywords we need to know about. The break keyword and the continue keyword. If you're inside a while loop or a loop of any kind and you see break, it bails out of the loop completely and goes to the next statement following the closing brace. Whereas if you click whereas if it says continue, it doesn't bail out of the loop, it jumps back up to the top of the loop again. So we will demonstrate first one and then the other. So here we're going to say if x is equal to 6, then break. And what's going to happen? X is currently equal to 3. Is 3 less than 10? It sure is. It prints 3. It adds 1 to it. Is x equal to 6? No, so it doesn't break. It comes back up here. Now that we've added 1 to it, x is 4. Is 4 less than 10? Sure is. It prints 4. We add 1 to it. X is now 5. Is 5 equal to 6? No, so we don't break. We come back up here. We print out x once again, and then we add 1 to it. Now x is equal to 6. If x is equal to 6, break. Well, that's finally true.
Yeah.
So it stops there. What this would print is 3, 4, 5, and then it would stop there. It wouldn't actually even print 6. That demonstrates break, but let's also throw in a continue. If x is even, in other words, if x mod 2 is equal to 0, we are going to continue. We're not going to print out any even numbers. So let's start this at 1 rather than 3 when we're talking about this. Okay, so x is equal to 1. X less than 10, it sure is. So we go inside the while loop and we're going to stay in it as long as this condition is true. Is x% 2 equal to 0? No, because it's an odd number. So we're not going to continue. So we'll print out 1. Then we add 1 to it and we check to see if it's equal to 6. It's not. So we come back up here and we do the loop again. Now x is equal to 2 because we added 1 to it. The while clause is still true. X% 2 is equal to 0. Well, what's 2% 2?
2% to 0.
Right, so this is true, so it'll continue, meaning it doesn't do anything after this. It jumps right back up here. And then it starts going in an infinite loop. So this is really not very well worded.
That's why it's breaking after 1.
Right. Really, to get this to work, we should do that before we start doing all those checks. Then it has at least a chance of working. And then it prints 3, 5, 7, and 9.
Sweet.
It never hit the break statement because we were skipping all even occurrences with this. So we never actually got to that one. So we could do while x is greater than 6, like that, just to force a break. And then it would print 3 and 5. And then that would be the last thing it would print. Now I'm making it slightly more convoluted than it should be, but you already know what while loop is, honestly. We've already been using them, even though this is the first, mention of them in the book, beyond the pseudocode section. I hope this makes sense. I hope you can see why this prints out 3 and then 5. If we set this equal to 0, it would print out 1, 3, and 5. Ooh, printed out 1, 3, 5, and 7. Okay, I can believe that. Because it stopped iterating once x was greater than 6. All right, I'm going to redo this logic one more time. Sorry. Here we go. If x is greater than 6, we break. If x is even, we continue. Now this is going to print out 1, 3, and 5. And then stop. Okay. Hope it makes sense, the difference between continue and break. I don't use continue in programming very much, to be honest. But breaks I do use a lot, typically when I'm doing a sentinel value or user query. Do you wish to continue? Yes, no. If they choose no, break out of the loop. Or enter -1 to exit. If data is equal to -1, then break. You can do both of those things without using a break statement, but then the syntax of the while clause becomes a little bit more complicated. And sometimes you have to do something. No, I'm not going to even go there. Let's stop there. Paste this into our notes. So break causes the code to exit the loop and start execution after the closing brace of the loop. Continue causes the code to repeat the loop immediately, skipping all the code after the continue statement. So looking at this, break would cause us to bail out and jump down to here and then do the very first thing that came after that. Like if it was a done statement, print done or something. So what this would do is it would print 1, 3, 5, and then done. Okay, guys. should just delete this question, but true or false? Java was invented by Sun Microsystems. And that is true.
Yeah.
It is now owned by Oracle because Oracle bought Sun Microsystems. That's true. Here's another true. Java was originally called Oak, true, and intended for development of appliances like TV cable boxes and microwave ovens and stuff, making it important that the code could run on a variety of platforms. That's all true. Java was called Oak, intended for appliances. This is just all stuff from chapter 1. There. 2 easy questions. So on our first day or 2 of lecturing, we talked about compiled versus interpreted languages. Compiled languages are when the programmer runs a program that turns the code into an executable, and then that executable is delivered to the customer. So compiled languages are things like C++ or assembler. And then there's interpreted languages. Interpreted languages are things where you give the end user the source code and then they run it. JavaScript is an example of that. Anything with the word script is an example of that. Python is an example of that. And then there are hybrid languages that are both compiled and interpreted. Java and C# are in hybrid languages. A compiler goes and makes the language into an intermediate form that looks like assembler, and then that intermediate form is what is given to the user to run. So, compiled languages, C++. Interpreted languages, anything with the word script in it. Python is a scripting language. Hybrid, Java. So when you march into the class, remember Java is a hybrid. And that there is absolutely nothing, there's no commonality between JavaScript and Java except that the word Java. The people who made up JavaScript were just riding on the coattails of the popularity of Java when they named it. What keyword do you use to declare a variable as constant? Final. Yep. I am going to delete that question. All right. We know how to write main. We know how to write something that'll print out a statement. System.out.println. I'm going to give you some versions of it with typos in it, like system.out.writeLine. Don't choose the right line. Choose the one that says println. So, what file extension do we use in our Java classes, in our Java programs? We name everything with the extension what? .java, right. That is the Java source code, and then it gets compiled into a file called .class. So that's the intermediate bytecode. And we can see those if we go out into the directories. After we do a compile in NetBeans, we can go and we can find the .class files. So what is the Java compiler? The Java compiler is the program that converts Java into bytecode so it can run. Yeah. NetBeans is actually the framework for it. I see the way you're answering it.
Yeah.
I didn't ask the question in such a way as to forbid you from entering that. So Java compiler, the program that converts source code, Java source code, to bytecode. Then there's the Java virtual machine. Java virtual machine is the thing that sits in every computer that has Java installed on it. And that's the one that converts bytecode into machine language to actually run. And then lastly, there's pseudocode. That's not a compiler or a runner at all. That's just a written description of the logic of a program. So if you see three things, if you see speed of light, and then you see something that has a lowercase letter like this, and then you see something that has an uppercase letter like this, what do we assume each one of these? One of these is probably a constant. Which one would we think is a constant? The one with the underscores is a constant, a named constant. If it starts with a lowercase s, that'll be a variable or a primitive type. So lowercase letters indicate variables. If something starts with an uppercase letter, it means that's a class, a reference type. And a better example of that would be string. If it has an uppercase letter in it, it's a reference type. If it's got a lowercase letter, like int or speed, you know it's a variable or a primitive type. And if it's all caps with underscores, it's a named constant. Those are conventions, but they're universally followed. I'm skipping the ones that are already well covered in our quiz, by the way. So that's why this material is not sounding real familiar. And this is all Chapter 1 stuff, which we didn't have the quiz on. So we know the three kinds of loops. Which of these are good programming practices? Is it a good idea to put a new line for your terminating braces? And what I mean by that is if you had this statement, if blah, 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 and then you have an opening brace, and then you had something here. Which is better, that or that? That's better. So go to a new line for your terminating and your opening braces. Is it a good idea to put your name up in a comment block up at the top? Yeah. Do you need to include a comment at the end of every single line of code? No, you don't want to put a line of comment on every single line of code. That just makes it harder to read, actually. Assembler programmers did that, but that's because assembler is insanely difficult to read. Is it a great idea to save space by putting as many lines as you can on the same line? No, you're not trying to save space in your program. Yeah. We could do this. We could remove all the spaces from our code. There's no reason to do that. Our naming conventions. Digits are okay, right? Digits are okay, underscores are okay, dollar signs are okay, letters are okay. All of these are good for identifiers. However, there is one rule. One of these cannot start a variable name, and which one is that?
Digits.
Yeah. Digits cannot start a variable name. So tax rate 1980 is fine, but 1980 tax rate is an error. What's the difference between initialization, declaration, and assignment? This is a declaration. This is an assignment. Initialization is when you do both at the same time. That's declaring. That's an assignment. Int a is equal to 3, that would be both. So it's initializing. We know that what the different kinds of data are. If you have quotes around it, it's a string. If it's got a decimal point in it, it's likely a double. If it's got single quotes around it, it's a character. If it doesn't have any floating points in it, that means it's an int or a long. And if it's a true or false, it's a Boolean, but this question doesn't even ask that. If it has an L at the end of it, it's a long. So 2L would definitely be a long. The faster I scroll, the easier the questions are. So be thankful I'm scrolling a lot. If you ask somebody for input and then allow them to type it in, what is that called? That's a prompt. Display a question and allow the user to enter data. That's called prompting, or a prompt. So what is the temperature? And then you have that scanner thing. So that's a prompt. We know the difference between /n, /t, and // for example, right? One of them means new line, one of them means tab, and the other one just prints out a single slash. Okay, we're going to have to skip that one. We haven't done that. Okay. So this stuff's the hard stuff. Everything else is just look at your quizzes that we've already done. And that'll be the easy stuff. It won't be too hard of an exam. It won't take you a full hour. But when I upload these notes, I'm not going to include all of this text here. But you can just go and watch the last 10 minutes of the video, tomorrow night. And if you want a refresher.